Section 7.4 covers the properties of logarithms, and in this section we're going to kind of talk about old properties that we already know about with exponential equations and kind of how those properties look on the logarithm side of things. So some of the properties you already know, kind of outlined here on the left-hand side. A to the third power times a to the fifth power. The kind of trick there is you add the exponents, you get a to the eighth power. The second property that we'll talk about, but in logarithm form, would be this division. When you divide a to the fifth by a to the third, you don't actually divide anything. You really just subtract the exponents, making that 5 minus 3, which is a squared. And then the last property, which is related to a to the third to the fifth power, you can multiply those exponents, you end up with a to the 15th. So these are three properties we already know, but we're going to talk about them again from the logarithm perspective. Again, logarithms are essentially the opposites of exponents. So in this case, when we talk about logarithms, we're actually talking about the exponents themselves. And you'll see in this first one, where our first rule, where you add the exponents, you're actually doing so because you're multiplying these values. So we're going to see that kind of in reverse for our logarithms. So the property first, the product property of logarithms, looks like this. And I guess this is better reading it from right to left rather than left to right. But what this says, if you have two logarithms that you're adding together, both with the same base, we can combine them not by physically adding anything, but by taking the values in the logarithms and multiplying them together. So yes, it says plus sign. Yes, you are adding logarithms, but adding logarithms is like adding exponents, and you're doing so because you're multiplying these values. Okay. You can see that in this example previously. So log base 3 of 10 plus log base 3 of 100. Again, this actually only works when you have the same base, by the way. It's not going to work if they have a different base. So these both have a base of 3, so it's going to combine them. You're adding these logarithms, but again, you're not physically adding any of these values. You're only taking the numbers inside the logarithms and multiplying them. So you take 10 and 100, and you multiply them together. So log base 3 of 10 times 100, which ends up being log base of 1,000. So the property, yes, you're adding, but you don't actually add anything. You just take the values and multiply. And that's kind of the trick, kind of like when you did with the exponents. Remember when you had the exponents, a to the third times a to the fifth? Yes, you're multiplying, but you're not actually multiplying anything. You combine them by adding the exponents, and essentially it's the same thing here. So we have log base 4 of 2 plus log base 4 of 32. But we're not actually going to add them. If we're going to combine these logarithms into one logarithm, we're going to do so by multiplying these numbers. 2 times 32, which gets us to log base 4 of 64. Same thing in all of these. Again, this only works if the base is the same. You'll see in all of these the bases match. So for E, it's got the base of 1/3. F's got the base of 5, and G's got the base of 6. Right. So when we combine them, again, adding really means multiplying these values in the logarithms. So this would be log with the base of 1/3, and we're going to multiply 27 times 1/9. Now, a lot of people struggle multiplying fractions, but multiplying 1/9 is the same as dividing by 9. So really, think of this as 27 divided by 9, which is the same as 3. But if you can't do those fractions, you can always just rely on a calculator. So log base 5 of 625 plus log base 5 of 25, same as the others. Take these values in the logarithms and multiply them together. So if you multiply 25 and 625, I believe it's 15,625. And our last one will be log base 6 of 36, because again, you're multiplying 4 times 9 to get 36. So that's the first property. The second property will be the quotient property, and this is based off of this rule. Remember, you're dividing in this case, but you're not actually going to divide anything. You subtracted those values instead of dividing them. So for logarithms, it's going to be the same idea, but kind of backwards. We'll be subtracting logarithms, but rather than actually subtracting anything, it's going to be the same as if we just divide them. So you can see log base 5 of 16 minus log base 5 of 2. Yes, it says subtracting, but you're not going to subtract these values. You're going to divide them. And the first one will always be divided by the second. So this would be 16 divided by 2, which would equal log of 8. So again, this only works if the bases are the same. but you take the numbers in those logarithms and you divide them when you see a subtraction sign. It's kind of counterintuitive, but again, we're talking about exponents here, and they don't necessarily abide by the same rules. All right, so we're going to combine these. Log base 2 of 32 minus log base 2 of 4. We are subtracting, but it doesn't mean we're actually subtracting. It just means we're going to divide the numbers in each logarithm. So this would be 32 divided by 4, which we can simplify as 8, log base 2 of 8. The next one, you would take log base 5, and you're going to divide 104. So it would be 100 divided by 4, which would equal log base 5 of 25. Because 100 divided by 4 is 25. And then our last one, again, whenever you're subtracting logarithms, if you want to combine them, you divide those values. So this would be 49 divided by 7, which would be log base 5 of 7. Now, one other thing I want to show you here. Oh, it's actually log base 7. I messed that up. The other thing I wanted to show you here was sort of, when you become an expert at logarithms, kind of how you can envision these problems. So notice our answer, log base 7 of 7. We mentioned this in section 7.3, but if these two numbers are the same, that logarithm is really equal to 1. So I know that that answer equals 1. If we go back to the question, again, we see the log base and those values the same, so I know that that is also, again, equal to 1. And I can also change this by doing a little bit of mental math. Log base 7 of 49, if I wanted to know what this equaled, remember you could change it into exponent form. This would be the same as 7 to question mark power equals 49. So essentially, what 7 to what power equals 49? And if you're wondering, you know, a lot of people would recognize that as that's the second power. So that log would be equal to 2. So this equation essentially says 2 minus 1 equals 1, which is true mathematically. We know that. So when you get really good at these logarithms, you sort of see that, you sort of learn how they work, and you can kind of see the math making sense. That's the point where I want to get you guys to eventually. The last property we're going to talk about is the power property of logarithms. So this is probably the most convenient and useful property that we're going to learn, at least from my experience it is. And it's this right here. So notice what's new to this logarithm. We had a base, we had an a value before, but now we have an exponent on that a value. This exponent's new. Sometimes it's good to have it there, sometimes it's not good to have it there. But what we can do is relocate that exponent to the front of our logarithm and have this as p times that logarithm. So that exponent just gets relocated out front. Again, since logarithms are exponents, having an exponent on an exponent means that you multiply them together, if that makes any sense. Logarithms are exponents. So if you have an exponent with an exponent, you can multiply them, which is why this p-value, even as an exponent, is mathematically equivalent to having this p-value there as something you can multiply to that logarithm. So a couple examples of that, just real fast. This would be log base 3 of 81 second power. Remember that 2 we could relocate to the front. So this would be the same as having 2 times the log of 381. And again, all these just moving the exponent to the front. So this would be the same as 3 times log base 5 of 1/5. Move this 4 here, would be the same as 4 times log of 10. Now remember, if you don't see a base, that means the base is also 10. Just a reminder. This would be 2 times log 5 of 25. And then this would be 20. Log base 8 of 4. So you can see all the exponents just moved to the front. This is very convenient for us on a lot of problems we'll do in the next few sections. All right? That'll be it for section 7.4.